In this video, I'm going to show you how we can evaluate whether an equation or an inequality is true or false for a given value. Let's start out by looking at the difference between equations and inequalities. So on the left-hand side, I've written an example of an equation. And in an equation, we have a left-hand side of an equal sign and a right-hand side of an equal sign. And the left-hand side and the right-hand side have to have the same value for the equation to be true. So literally, the equal sign just means this and this are equal in value to each other. If I know that this is a true equation, I can solve for n. So in this case, if this equation is true, n must be equal to 6 because 6 plus 4 equals 10. In the middle and on the right, I have examples of what's called inequalities. And it's an inequality because we're using a less than or a greater than sign. So that means that this side of the expression n plus 4 is less than 10. This side and this side, the left-hand side and the right-hand side, are not equal. That's why we call them an inequality. Over here, the left-hand side is greater than 10. Again, this side and this side are not equal. So if I were to take my value of n equals 6 from my equation, I can plug that in over here and do 6 plus 4. And I can discover that these two inequalities are both false because 6 plus 4 is 10 and 10 is not less than 10. Over here, 6 plus 4 is 10 and 10 is not greater than 10. Whereas with the equation 10 equals 10, that is true. So with inequalities and equations, if I know the value of my variable, I can test whether equations and inequalities are true or false simply by substituting the value of that variable and then checking the left-hand side versus the right-hand side. So I've created some examples to look at that we can check for whether they are true or false. And for each of these examples, we're going to evaluate them for n equals 8. So on number 1 here, I have 2n. 2n means 2 times n. So I'm going to substitute 8 for n. 2 times 8 equals 16. Now, my equation says 2n equals 28. 2 times 8 is 16, so that tells me that my equation is false. 2n does not equal 28. Number 2 is n divided by 2 equals 4. I'm going to substitute 8 for n to check whether this is true or false. 8 divided by 2 does equal 4, so this is a true equation. Number 3 says 4n minus 3 is less than 30. So on the left-hand side, 4n means 4 times n. So 4 times 8 minus 3 must be less than 30 for it to be true. I have to follow the order of operations, which tells me that multiplication comes first. 32 minus 3 is 29, and 29 is less than 30, so this is a true equation. Number 4 says n over 8 is greater than 1. N over 8 is the same thing as n divided by 8, so when I substitute in 8 for it, I'm going to write it out like this. 8 divided by 8 equals 1, and 1 is not greater than 1, so that is not a true statement. This is false. Number 5 says n squared is less than 81. If n equals 8, 8 squared equals 64. 64 is less than 81, so that is true. And in the last example, I have n minus 2 plus 3 is supposed to be greater than 4, so let's see if that's true. I'll substitute 2 there and rewrite everything. I'll follow the order of operations, which says do addition and subtraction the same step, but from left to right. 8 minus 2 is 6. 6 plus 3 is 9. And 9 is greater than 8, so this is a true inequality.